All right, this is Thursday, August 25th, period 4, calc, and I would do kind of putting these videos up as soon as I can on Blackboard. All right, what is the, you want to start with number 1?
Yeah.
Okay.
Yeah.
Does anyone want to do number 1? I encourage participation. Want to knock it out? Go ahead, please. Harrison, right? What's your name? You're Henry, sorry. 120 kids, I apologize. Alright. Don't take it personally.
You can't put your elbow on the board.
I'm just a student, so I might ask questions to understand.
Alright, dude. You never do anything.
Just be careful, Henley. It's very sensitive, so it'll pick up like when you touch the paper.
Yeah.
Just let you know.
Do I have to explain it, or can I just?
Yeah, if you could, you know, it's up to you. You could probably just write it down and say, ask for any questions.
Alright.
I would appreciate if you could explain it, though.
Alright.
Can I use your stapler?
Yes.
Explain it while I'm doing it, or?
Up to you. You're the teacher.
Alright. Okay.
I want you to think that when you're up there, you're there to help everyone.
I do. Alright, so this is what you start out with. So I start with the top, and with the exponent, so exponent we multiply, so x to the 8th, minus negative 6. And when you have a negative exponent, it moves to the bottom, so I moved minus 6 to the bottom. 6 plus 5 is 11, y to the 11th, and that's the same thing as x to the negative 3rd, so 8 minus 3.
So you're saying if we move it up or move it down, you just change the sign of the exponent?
Yeah.
Anyone have any questions? All right, very good. Next one.
Pretty good. Would it be okay to use it in the form x to the 5th, y to the negative 11th?
You could, but typically we don't write things for negative exponents.
I know,
Rather
but
write it rationally.
they technically did.
I personally don't care, just know that it's either way, it's probably good. Anyone want to do number 2? You can do probably say it out loud too. Find the domain of f of x, express your answer in interval notation. So one thing we're assuming here is that we only want to have real values for our functions.
Oh, 0.
Not just the divisor being 0 is a different issue than the divisor being the square root of negative. But we don't want division by 0, and we also are assuming that our function can only have real values.
Can I go to the restroom?
Can you?
May I?
You may.
Is there a pass?
There is a pass.
You only need one. I honestly don't understand.
Okay, so
yeah.
for this, you can have the square root of 0, right? But you can't have the square root of a negative number. So say this was like negative 3 plus 2, it would be square root of negative 1, so that doesn't work.
Okay. Can you show a step between the given and your interval elimination? Like, I don't want to say this without just giving it away. Maybe I'll just say it. X plus 2 must be greater than 0. Can you write that? This will help. This is really the step in between, so you say, okay. X plus, now, anyone have any questions about that? Why that must be true? X plus 2 must be greater than 0. Not only can that radically cannot be negative, but it also cannot be 0 because you have to divided by 0. Find difference between x plus 2 greater than 0 and x plus 2, or x plus 2 is greater or equal to 0. So it cannot be 0, it must be greater than 0 for real values. Okay. Now you guys see how she comes up with, okay, now therefore subtracting from the sides, x must be greater than -2, so it's a parentheses, not a bracket, because it does not include. Remember, the bracket is what includes the actual, it's inclusive of that point. What's that? I know. So it's parentheses because it cannot be -2. It can be -1.999, but it can't be -2.
So that can be everything, like, basically -1 up, and then, obviously y can be negative.
Well, it could be -1.99, for example.
Yeah,
Like
okay.
everything, you know, as close to -2, but not -2 to the right.
So that's excluding the negative.
Yes, the bracket is when we say it can be -2. So the difference between the bracket and the parentheses. There's no questions about this one. Someone wanted to do number 3? Sure. Thank you. You can just do a new page.
Yeah, but you can't take it out of both. Since it's not by addition. Yeah, but there's not an x. So you can take out x. I mean, I don't know.
I did part B, that's fine. Part A and part B.
Are there any restrictions on our variable?
I guess X can't be 1.
Is that the only restriction?
I thought part of the question I could do that.
It is technically yes.
Oh.
Because if you leave like that, you're telling me that there is no restriction.
So it just is simplified. Yeah, it just
Mhm.
I didn't know that I had to put restrictions. I don't know.
Yeah.
I don't know how to do that.
This is an important concept to focus on because we have restrictions for a reason, because division by 0 is undefined in math. So it is important.
Why did you have to do it like that? Why couldn't you just, like...
Typically, you can do like a comma too, and just state what x cannot be.
Oh my god.
Does anyone not understand the factoring part? Raise your hand if you want to see how that was factored in case you need a refresher on factoring. Okay, so what can x not be? And this is also important because we talked about removable discontinuities versus non-removable discontinuities, asymptotes versus wholes, so it's very important.
It can't be 1.
Yeah,
That's all I can think of. I'm sure there's something else that I missed.
There is something else.
What is it? I don't know.
0.
There you are, what's going on?
Why can't it be -1 then?
I don't know, I just guessed.
Oh, okay.
You can have 0 on top.
Well,
X can't be 0.
if you mark, it's going to show you as absence.
Why couldn't X be?
Because you have
Yeah, but like
They'll probably correct us,
Yeah, it
right?
can't be 1.
So, alright, so,
I don't know.
I need to say this. The restrictions are based on the original function.
Oh, so you what, you like, so it can't be -3 also?
Correct, because looking at the original function, you would end up having division by 0 if that's equal to -3.
Okay. And then, so then here it'd also be +1?
So right, so the full restrictions are x cannot be 1 nor -3.
Or -3, what about, oh yeah, it's still 1. Yeah, okay. Alright, do you want me to do part B?
Sure. I wouldn't necessarily mark off, because you're right, it does just say simplify, but at the same time, it's a very important concept. It's better to have it than it is to not have it, say that.
Okay. Fair enough. Okay, can't find my words here.
The restrictions.
Oh, okay. Can you show me how you went from the numerator being the square root of the sum of x8 and x4 to what you had written?
I don't know. Let me see the question.
Oh, I forgot to do that.
True. Yeah, I mean, if we just distribute this out, it'll work out.
See, I did not do
And then
that.
most of them square root x to the
Could you show it to us? Just
yeah,
can you
I
show
just
it
have
to
it
us?
through the problem. Okay, x to the plus x to the 4th. I'll just work with this part since that part's already there. Yeah, whatever, it's fine. So the square root of that would be x to the 4th plus, because you're taking square root, which means you're just dividing the x number by 2, and then plus x squared. And that's how you get that to there. So, and then this stays the same because you're not doing anything to it.
Just to be clear, can you show me how that becomes that?
Like,
8
I
doesn't
don't,
go to 4 because it's not a perfect square.
I don't know.
Oh, okay, then you
exactly
actually
what
just
it
use the
is.
square root of the exponent.
Yeah,
This is what I want to see. Just because I know you might get it, no, you might get it, that's fine. Just so everyone, because I want everyone to be on the same.
That doesn't work.
Well, it's not the
Yeah.
exponent, I think it is one
But
half.
that's not the answer.
Okay. How did you, I don't understand what happened.
Okay, thank you. If that happens, let me know, okay? All right, so what's the original problem? What's the original problem?
Square root of 8 squared.
X to the
What's the original problem?
X to the square root of x to the 8
Okay.
plus x to the 4th over x squared plus 1.
Thank you. Okay, this is what I want to see. These two have a common factor.
What?
I am factoring out x to the 4th from this binomial. Because if I distribute this in, it wouldn't be this.
Oh, I see, yeah, you just did it weird.
I did it weird.
Oh, yeah, because I didn't write that, because I just took it out.
Yeah, I just put it on the outside.
Well, let's be clear. So I'm just keeping it underneath the radical for now because we're going to obey the rules of radicals right now. So x squared, what is, so now this can be viewed as, to make it very clear, now I'm allowed to break up a product written as two separate radicals. Square root of x to the 4th. So we have x squared square root of x to the 4th plus 1 over x squared plus 1. Can we go any further?
So like the rule with radicals and that they're like actually like square or whatever, like you don't just like subtract.
What do you mean?
The exponents, like when there's exponents and radicals, like
Because those are being added together, not multiplied, you can't use that rule. If the denominator was being multiplied at all, then you could use your subtraction rule with exponent.
no, I'm just asking like with exponents in general, you just take the actual like, square root of it and you don't just like subtract it like you would if you were dividing.
Okay, maybe this will answer your question. This could be written as x to the 8th plus x to the 4th to the 1/2 power.
Oh, okay.
Think of it like that.
But then you can still multiply 8 by 1/2.
This would be 8 to the 1/2. So it's x to the 8th to the 1/2. There's no exponent.
Yes,
You can't multiply.
8 times 1/2.
Yeah.
Because when
In case
exponent
it-
is like,
Exponent.
I know,
We could get the same answer.
Let's be absolutely clear about this. Let's not forget the basic fundamentals here.
Yeah, that's what I'm saying. So if it's x to the 8th plus x to the 4th, parentheses to the 1/2, because that's what the square rooting is. Why can't you just do it x to the 4th plus x to the 2nd?
Yeah, doesn't that work? Because that's what
That's
our
what
thought
we're
process
doing.
was.
No, it does not work.
Why?
When did you learn that?
I don't know.
I never learned that.
Well, if you
Trying to just say it.
multiply. I guess not because you have to boil it out.
However,
Yeah, how is that different? We've always done that.
From the outside of parentheses to the inside.
Yeah, how is that different than?
Because you're adding x to the 8th plus x to the 4th times x to the 8th.
We did.
let's not get
Yeah, we
addition
did.
confused with multiplication here.
Yeah, I get what you're saying. I see what you're saying. Oh,
when it's bound by an addition.
What would you do?
Oh.
Because x
This
plus-
absolutely does work because what is factoring? What is factoring? Extremely important math. What is it? What does factoring allow us to do? If you had explained it to someone that is starting off as a freshman.
To break a big thing and put it into parts. So
What factoring allows you to do is change a sum to a product, which is what we really want, because we can simplify products of radicals very easily.
What's your question? So for, it says x squared, like the final thing you got, it's x4 plus 1. X to the 4th plus 1. Could it, if you took the square root of that, wouldn't that be x squared plus 1? So you cancel that out and you just get x squared.
Let's see if it is. So we should be able to work in the other direction. So what is x squared plus 1 squared?
It's not going to work this time.
No,
It does not equal x to the 4th plus 1.
Alright, so yeah,
I mean, you can do it the long way and find out that
I believe you.
What's that?
I believe you. You don't have to work it out.
Okay.
Oh yeah, because we have to use a foil.
Foil at worst.
Do you guys remember what this is?
First
Yeah,
and
you have to
last.
double it. So you can get
Yeah, to AB.
Yes. This guys exists.
Right, okay, that's.
Yes.
Go back to the original equation.
Yes, ma'am.
Could you just square the entire, like the first one, so you don't have to deal with
Right. Square what?
the whole equation? Like top and bottom.
This is not an equation.
Just the whole thing.
Well, let's be clear. This is not an equation. No, because you make a very good. Okay. We're gonna develop fundamentals. That's good. The summer it's been a long time, so that's good. Fundamentals. Math is all fundamentals. If there's a crack down here, we're gonna really mess up when we start doing integration. Okay, so let's do this. Watch this. If I say, guys, if I say A equals B, you are allowed to do whatever you want to both sides of the equation. It will maintain truth except division by 0. Undefined equals undefined. Okay, that's kind of silly. Besides that, this is completely true. Okay, I want you to understand this. That let's say we have, this is given, you are given A over B. You cannot just assume that A over B is equal to A squared over B squared. What is the only thing we're allowed to do to take one fraction and make it an equivalent fraction? Multiply or divide.
By the same number on top and bottom.
Thank you. Thank you. Is 5 halves equal to 25 fourths if I spread the top and the bottom?
No.
Okay. All right. So it is.
What are the restrictions on that? Do we have to write the restrictions for this?
Absolutely, we're getting there.
Okay.
And in fact, I would write the restrictions from the very beginning because otherwise you will forget.
True.
You will forget. And that was a big emphasis I had in the last 2 periods. And I would go ahead and box your restriction too. Because you'll get to the end, and then it's not boxed, so it's like, oh, I'm done. And even sometimes you'll box it and you'll be like, I'm done, and you'll forget. I'm like, oh my god. I even have a box here that A can, or X cannot equal 3, and I have X equals 3 circled at the bottom of my paper, and you're looking at it, and you're not getting full credit for the problem, and you're like, I hate myself. We don't want that feeling. We don't want that.
Every day.
Not that extreme, but okay. So, what factoring allows us to convert a sum to a product. That is hugely, it creates huge advantage in mathematics. Because now this is nice, because now I can write it like this. Now that guy breaks down nicely to x squared. I don't know. Okay, we know sum of 2 cubes, difference of 2 cubes, difference of squares. Those are the 3 guys that we should recognize quickly. There's no sum of squares. There's no, right? There's nothing. Okay. So this is.
We're good.
What's the cube one?
Yeah, I know the squares.
You know.
If we have the sum of 2 cubes. I think that's it.
Yeah, because it's just squared and then.
Oh. Okay.
I think that's it. I don't really memorize it.
I got you.
But I know to recognize it. If I have to look at the formula, I will. I really don't want you guys to focus on memorizing these.
What it is.
It's not Precalculus. It's not really.
So we can
But you
find
guys
the
should definitely be
restrictions.
smart enough to you know, you should be able to spot it in case, you know. It's not a huge focus.
It's not.
Not a huge focus. I would probably even just give you that formula if we had to do it on test, but it's probably not going to be on a test. So we are back to, okay, so we're done here. Does anyone have any concerns about, are we completely done yet? Or can you show me, Mr. Gross, that we definitely cannot go any further? Yes.
That's good. Well, can we do the restrictions first?
Okay, yeah, so of course I need to state the restrictions. So, restrictions, what are they?
You can't have a restriction.
And we are assuming for real values only.
It can be anything, right?
I think it can be anything.
Because even if you have a negative number when it gets.
And remember, it's based on the original. And this guy still is the original. We just factored something out and showed it factored.
Yeah.
So anything raised to an even exponent is going to make it positive. So x could be any real value.
Cool.
I don't know how to do. No, wait, just kidding. Yeah, that's the one I was going for, but we got
Oh,
a
is
little
this what you
while.
were talking about? When you have the fourth,
I really hope I don't have to go over
You
4.
could cancel everything.
Otherwise, I'm
but,
actually kind of
like,
scared if I have to go over 4.
Because the answer, in fact, like, when you cancel it, like, that's, but, yeah, number 6, we all know that.
No one wants to see 5? Raise your hand if you want to see 5. If one person wants to see 5, we'll do 5.
Really quickly, I just have a question.
Yes.
So the answer is x equals 9, but x equals 9 and negative 3, but because of the restriction in the denominator of the second one over x plus 3, is that why x equals negative 3? Is that why they
Yeah, I didn't even do 5, and I immediately can tell that x cannot equal negative 3.
Because of the denominator? Okay, because when you like figure it out, x can equal 9 or negative 3, but because of that, it can equal negative 3,
Yeah.
so you just do 9.
Yeah, that makes negative 3 an extraneous solution. In other words, it's not part of the solution.
You have to write that.
Yeah, I'm not going to give you full credit if you say x can equal negative 3.
No, but like,
No,
if you
like,
don't write X.
If you write like x can't equal negative 3 versus writing nothing.
It's kind of risky, but if you can remember to know, if you can remember it, that's fine. I mean, I'm looking for x equals, was it 9? Was that the other
Yeah, so
solution?
you don't have
If
to
you
write
if say 9 is the other solution, is the one solution that works, that's the only one I want to see clearly circled. I don't want you to circle, oh, it can be 9, or it could be negative 3. Yeah, so if you do the restriction thing in your head, that's fine. I personally would not do that because I would forget. So I recommend in general, I think it's the best thing to do is just write your restrictions from the very beginning. Yeah. Okay. So 5 is good. Okay, 6.
Yeah,
Let's definitely do 6. Okay.
Numero 6.
You get number 6?
Please explain it the best you can.
like thoroughly.
Don't just skip step training.
So if you look at the
Did I hear someone say that they lost their track of those textbooks?
No,
Before?
not me. What's it?
I mean, it's not my loss. I just.
So if you look at that first thing, it's also equal to b to the negative second. Does that make sense to everybody?
Yeah.
So you have 1 over b squared.
Can you write the original problem, please?
Sure.
Thank you.
Yeah, because I don't know what.
Oh, we could have done this. She just did that.
Wait,
Hold up.
She's just
writing
it.
this
She
down.
really hasn't done anything.
Oh, okay.
Does that make sense?
Yeah,
It's
it's
there. Alright, so 1 over b squared is also b to the negative squared plus a squared. And then the same thing with this one here, a to the negative squared plus b squared. And then I just flip flop those two. So,
Wait,
you flip flop
Yeah.
those.
Question that is, if it's negative and if you're adding something together, how can
You
you
have to flip the whole thing.
It's
Wait, what do you want to do?
So I simplified this to b
I
to
hear
the
you.
negative squared.
Now do the
And
next
then
step.
because those are negative, they switch, don't they?
But they can't because
They're
they're
additional.
additional.
Maybe if there were a product going on.
Yeah, you were multiplying because
Never mind, I mean, I got the answer.
I know there's ways to get the answer, it's just not right.
You instantly got the answer though.
Yeah, I did.
So don't you have to multiply the top and the bottom by a to the negative 2 plus b squared? Isn't that what you do?
I'll let someone else take a shot at it.
Okay. I did, you know how like the right here? Yeah. Took that by itself, and I worked with it first. Is that not okay?
Well, can you explain, what do you mean?
I did you know how like they're both fractions?
Okay.
I did the reciprocal of one.
She multiplied them.
Yeah.
And took the reciprocal of 1. She did like 1 over b squared
Times
a
a
squared.
squared over 1.
Yeah, because it's a fraction divided by a fraction.
Maybe I
She
should have
did
done
the
I didn't want to say that out loud, but, I mean, you can show me what you're talking about. I'll stop you if it's no bueno. Can you explain what that is? Can you explain what that is? Yeah, what's going on?
Okay, so I took this and this, and you have to do the reciprocal of the top one.
What do you
On the
mean,
bottom
do
line.
the reciprocal? What does that mean?
You take the reciprocal and multiply it by the fraction.
I think he knows, I think he's trying to.
Oh, no, yeah, I know exactly what to do. I'm playing the, I have to, like, if I'm a student who learn this, like, I feel lost.
I think the real question is, are you allowed?
Unless you guys are doing it, move on.
Are you allowed to
That's
actually?
crazy. Am I allowed to do that though? I mean, we need to know if it's like good.
Is this real?
And you know, you may be good, but I'm just confused, so I'm just gonna do it, and if it happens to make sense, so what you did, then perfect, but I'll show you the way I would do it.
But is this right?
I don't know, I haven't done the problem yet.
Wait, can you just put this and say if that's legal or not? Like,
I'm not sure what she's trying to demonstrate here.
she said
So what she did is she.
No, seriously, I'm not playing dumb now.
No, she looked like she took them separately.
She said, I don't care that this is a sum here, I just, which you're not allowed to do.
Okay, that's what we're. Okay,
Okay. But you coincidentally got the correct answer.
Yeah. Well, so did Mackenzie, but she didn't do it right either.
Wow,
So
you
how
guys
do you
like
do it
the
right?
luckiest mathematicians ever.
And we did it, but we got, like, it wasn't right. That's illegal too. There's ways to do it.
I will leave that there, and then if we want to compare, we
So
can.
if I get the right answer on
What's
my
the-
test,
what's the
it
original
doesn't
problem?
matter how I did it. Okay, b to the 1/2
You don't
plus
say it out
a
loud.
squared. This is amazing.
Oh, yeah.
Wow. Why did you do this? A squared. Over. Whatever, yeah.
One
This is
over
legal,
a
maybe.
squared plus b squared.
Okay.
Can't do anything.
What's the first step?
I
Regardless
Maybe
of what we're
didn't
doing.
say to a to the negative 2.
Before that,
I don't know.
because I wanted this, because you will forget.
Restriction.
Yes, okay. What are the restrictions?
And it can't be b and
Oh,
a
they're
can't be
definitely
0.
restrictions here.
Zero.
A
Gotta chill.
and B cannot equal 0.
That's a good 9. A and 9.
A and B cannot equal 0. A or B, comma, right, okay? What's that? No. Division by 0 is undefined. 1 divided by 0.
Yeah, but B can still be
But b is a fraction of
No.
Still right.
Either one cannot be 0. I'm not saying that it both cannot be 0 at the same time. I'm saying either or cannot be 0. Okay. So the way when you have a complex fraction like this, the thinking that you need to have is I need to make it so that it's no longer a complex fraction, since that I want to combine these two and combine these two individually. Okay. So how do I combine these two?
Find the common denominator.
What is the common denominator of these two?
You can make it b. You can make it b squared. If you multiply the a
The least common denominator is b squared. Because what's the denominator of a squared?
1.
1. Okay, so I'm going to, because I don't have room, we know this to be true. I'm just going to, if I was really good at this, I could just select it and drag it.
Yeah, you did it there. How do you make it
smaller.
Use the X.
How do I
The
drag
X,
this?
The X at the top left. There you go.
Thank
I didn't know
you.
that.
Thank
Okay,
beautiful.
No. Okay.
Okay, so the common denominator is b squared. This already has that, so it's going to be 1 over b squared plus, I'm going to multiply the top and the bottom, because imagine this is over 1. I'm going to multiply the top and the bottom by b squared.
So we can multiply it by a number?
You are allowed to multiply the top and the bottom of any fraction by the same value except 0. You have an equivalent
But
fraction.
don't
That's
you
the only
also
thing you're allowed to do.
multiply it by the original 1 over b squared? Like when
I'm-
you do it, so it's 1 over b squared plus a squared over 1, say, and then you have to multiply that whole thing by b squared over b squared, and so you have to, it would wind up being 1 over b to the 4th.
No,
It's
no,
like one whole thing.
You're just changing the one fraction. You take the a squared over 1 and multiply that by 1.
But you don't multiply the other one.
No, you don't multiply that. No, that's how you find a common
Saying multiplying it doesn't want it to do anything.
I like the way you think, Grace, in terms of if I was dealing with an equation. This is not an equation, this is an expression. If you deal with an equation, I'm going to multiply by the LCD by both sides all day long until immediately you're at a fraction. I hate fractions. But be careful, this is an expression. So here's from a previous class. I would immediately multiply both sides by x minus 3 to get rid of x minus 3 in this example here. But this here is an expression. I put an equal sign, doesn't make an equation. We were given an expression.
Yeah.
Okay? So let's just focus on combining these two into one fraction. Back to like the basics, okay?
Oh, I see.
Right.
Okay, I do it a little. Okay, I actually understand now. Makes sense.
Okay?
Equals.
All over. What about these guys here? What's going on here? What's the LCD? A squared, yeah. So we're going to have 1 over a squared plus a squared b squared all over a squared. You can quickly check this. I'll be up there. Right? Yeah, I mean, I have to do a new slide, so you can make it smaller by selecting it and doing the shrink. Okay, awesome. Thank you.
And then you can do the
So this is where we are now.
Wow, and then you can like cancel.
Yeah, just the corner.
You get rid of the 1 plus. You just
I could probably just start with a thinner style
where?
so that it's not so crazy. Okay. Can you guys see this though?
Yeah.
Just small class. You guys come to the front if you can't see it.
It's 1 plus that.
So now where are we?
So just add them. So yeah.
Now it's 1 plus a squared b squared all over b squared all over the large, the major fraction bar.
Then you can multiply by the reciprocal.
Now, this is advantageous because now we can just do, to divide by a number, just as multiply by its reciprocal. So now this is the same thing as, let's go ahead and, I thought I had red, but I guess I didn't. Let's go ahead and flip it. So we have 1 plus a squared b squared all over b squared. Let's make it multiplication. So we're going to multiply by the reciprocal. And that is quite lovely because what goes on here? A squared over b squared. This is still the restriction. Because the restriction, I'll state it again to emphasize, the restriction is based on the original expression, not some simplified form later down the line. These two go hand in hand. So I guess what we'll do is we'll just pick back up with this next class. Good. Good fundamentals. Thank you guys.